71% of the organizations are regularly using generative AI, but only 17% are getting real measurable business value from it. Architectural decisions matter far more than model choices. So that means, as an engineer in 2026, you guys need to become intent drivers, and that gap between a demo and a production, between an excitement to build something versus the outcome and results and ROI, there are a lot of scaling issues which come with that. What RAG is becoming is something far more powerful, and the money flowing into it tells you everything. Fine tuning involves changing the model's weights for better task specific performance. So, guys, we're gonna start. I'm assuming that you guys have seen the videos which are on YouTube, the past ones, because that will definitely give you a good idea about what's going to be covered in this chapter. This is an interesting and important chapter. Wherever you are going, any place, this chapter is important for all the companies. In any company you want to join in. Hi everyone, and welcome. It's Aditya Chhabra, founder and CTO of CreateBytes, and the companies which you see there, which are Yug AI, Alteryx Lab, most importantly, the Academy, which we are now running and you guys are part of, which is CBA. And before we start, I want to give you one number, and which is basically McKinsey published this last year. 71% of the organizations are regularly using generative AI, but only 17% are getting real measurable business value from it. Think about it for a second. Nearly 3/4 of companies are using this technology, and barely 1 in 6 is actually getting returns from it. And it's an important number, and we'll basically deep dive into why and what's happening. And that gap between a demo and a production, between, let's say, an excitement to build something versus the outcome and results and ROI, that's what we are gonna cover today. And RAG, which is like we'll be jumping into deep dive of RAG and advanced RAG, is right at the center of it. So let's proceed. And I'm gonna quickly jump towards advanced RAG. And you guys should understand like what's this advanced RAG means. So I want to understand something right at the top before get into more detail, because you've probably seen these articles everywhere where you would have seen people writing RAG is dead. And this is like 2026, January, February, people are writing in on the Instagrams, RAG is dead. And even there are videos on YouTube about it. People posting confidently on LinkedIn, on Medium, on YouTube, everywhere that it's over. But here's the honest picture. In January 2026, VentureBeat ran a piece with exactly this take. And the counter argument that came back from the enterprise AI community was just as loud against this. Because here what's actually happening. The name version of RAG is dead, which is basically back 2-3 years back, the way you were using it. Let's say we grab a PDF, drop it into 512 token chunks, dump into, let's say, a Pinecone or a better DB, and we hope for the better version of it. That approach was never production ready, and it was like a difficult thing to use it at the live level scenarios. And like with a basic scenario, there are a lot of scaling issues which come with that. What RAG is becoming is something far more powerful, and the money flowing into it tells you everything. Snowflake, it paid $250 million to acquire crunchy data. A PostgreSQL, like you would have heard about PostgreSQL, it's a database which follows ACID properties, quite powerful. And what they've done, it just hired PostgreSQL DB specifically to power RAG infrastructure. Databricks spent $1 billion on Neon. Superbase raised $100 million at a $5 billion valuation. These are not companies betting on something that's dying. So we need to understand there's money flowing in. Companies are using it. Then what's happening? That's the thing which we'll understand. So there are massive bets on data layer that makes RAG work. And by the end of today, you'll understand exactly why these bets make sense. Every concept comes with a code. Every complex idea gets an analogy first. So you guys need to understand what exactly does it mean and how it is used. And we'll jump directly towards an important concept and deep dive into what basically RAG and fine tuning. But before that, I want to cover a little bit about RAG too, because we have covered it in our previous chapters and all. So RAG is Retrieval-Augmented Generation. It combines retrieval of relevant information with generative AI for dynamic responses. So let's take a real example. Imagine you have brilliant so I would rather say that like you have used it yourself. So think of it like in your colleague, or let's say person who is your neighbor, one of the smartest people you know, think of that person as an example. But their last update was 2023. That is, they've not updated. So they haven't read a single thing after that. Then you call him, what did SEBI announce this morning? Let's say you ask a question. They'll be blank. That information simply doesn't exist in the memory. And that's where large language models, let's say GPT, Claude, Gemini, they all are quite good. But they have a frozen thing, which is like after this time, they may not be able to give you generative AI answers, and they may have to, like, unless they have an option to go on Google, search about it, and then come up with their own answers. Now, this is solved by RAG. You build a retrieval system that pulls relevant information from your documents and data sources and feeds it to the large language model exactly when it needs it. The large language model is the brain. RAG is the research assistant who runs to the shelf, grabs the right pages, and puts them on the desk before the brain starts work. The use case on this side, again, if you just think at a very global level, are legal research, customer support, medical data. These are exactly the domains where static large language models may not be useful to that extent. And the other problem which comes in is, again, hallucination with these. And here's where it gets genuinely exciting in terms of where we are right. Zendesk Anthropic acquired a company called Unleash in December 2025, specifically to bring permission-based RAG into the enterprise plan. Employees asking questions in Slack and Microsoft Teams, getting answers grounded in the company's actual knowledge base in real time. That's not a proof of concept. That's a billion-dollar company embedding RAG into the product, which is used by their customers on a daily basis. ServiceNow also did the same. Workday did the same again. The technology is now inside the tools your enterprise or let's say the clients uses on a regular basis. So we need to understand the importance of it. And now, because I've just covered a very high level thing about RAG, I'm going to give a difference between prompting when you're doing prompting versus when you do fine tuning versus when you do RAG. Because these three things have some correlation but are very, very independent from each other. Think about it. The slide is where you can basically think about it for a second. Like let's take an example of fine tuning. Fine tuning involves changing the model's weights for better task specific performances. So let's say deep domain specialization, time consuming and expensive. Okay. You're backing knowledge in all the training data and it is important to understand this. Okay. So for example, let's say you have XYZ data set. You basically try to figure out what can be the right model weights and use it. Again, RAG, it retrieves. You don't do any kind of fine-tune training. It's just retrieving the external data dynamically for more accurate real-time responses. You don't touch the weights at all. You inject fresh data at every query which you're writing. The decision framework on the side is right. Like if we look at now the prompting, it is like a general scenario where you write in English text and basically getting an answer. And you can basically use prompting in terms of using it with RAG for asking questions. You can use it with large language models or a fine-tuned model. Now, think about the context that makes the slide, let's say, land harder in your brain. And give you a very practical example. There's a company, Flowtorch, which released a comprehensive RAG benchmark study in February 2026. Now, one question which will come in your mind is, what is a benchmark study? Benchmark study is nothing but basically a way to say that, okay, which thing works better because the outcome is different in different expectations. So we must be knowing about some concepts like F1 score and all which comes in. Okay, so what you do, you take a data set which can be called as a gold standard data and then you benchmark it against that data to figure out how good your system performs. Again, Flowtorch released a comprehensive RAG benchmark study in February 2026 and you guys should go through that and maybe search about it. We'll share the link at the end. Testing 7 different approaches across thousands of academic papers. The AI community was genuinely surprised by some of the results and even I was like, wow, this can happen. There are a lot of papers which got released in that duration. So you guys should always keep tab of the open source papers and a lot of them, I think they are being shared on Insta and on WhatsApp community. Most sophisticated approaches didn't always win and we need to understand this concept. The study showed that architectural decisions matter far more than model choices. So that also means as an engineer in 2026, you guys need to become intent drivers. You guys need to follow a framework and I coined that term which is called as AWARE, Agentic Workflow for Real-Time Evolution, Adaptive Real-Time Evolution, which is called as AWARE, which is a different way than agile methodology which you follow in SDLC cycle. Okay, but we'll jump into it in next couple of lectures where we get into AWARE. But what we need to understand is that you guys as an engineers, you need to think at an architectural level and this study clearly depicts that and not like, let's say you are using Anthropic, Codex, it doesn't matter to that extent. So you guys need to understand. The teams who understand the trade-off between these three approaches and know when to use which one, it's important whose outcome of the system changes according to that. So we need to know that like when we are building it, think at the architecture level, think at the systems level to be very exact. So we'll basically get into the detail about it. But the crux of the matter is as an engineers, you guys need to come out of the execution phase and get inside more strategy planning and most importantly, the core systems level thinking process whenever you're building something or building a product. So now this is important. RAG plus fine tuning, combining both of them together. Real-time data access with tailored responses. That's the benefit which we saw in the previous slide. Okay. So again, you have tailored responses. Why? Because you're fine tuning and real-time data access because you have RAG. So one of the examples is healthcare, where you can see that fine tuning on medical literature can be done first. The model now genuinely speaks in a very, let's say, medical language scenario where it can use medical terms and all. Then you add a RAG layer on top of it and it retrieves latest clinical research, drug interactions, patient records at the query time. Domain depth from the fine tuning, freshness from the RAG. That's the combination of RAG plus fine tuning. And this is something which is very, very common to use in the industry. Now, if you look at the code, you'll see a particular thing called as fine tune model on domain data set. Then you have create retriever and then you have generate from retrieve results. These lines complete the pipeline and that is it. Very simple. Okay. What made this combination dramatically more practical in 2025 was LoRa and QLoRa reaching a very good maturity. So again, we'll get into LoRa and QLoRa too again, and it was being covered in past too. So look at the lectures which are like I think second and third to get an idea. So instead of retrieving billions of parameters, you train a small adapter layer, millions of parameters, fraction of the cost, because that small adapter layer again is just for millions of parameters. So you just train that adapter layer, which is fraction of the cost and same domain specialization. And even I am using it in CreateBytes to that extent, where most serious enterprises and teams doing RAG as fine tuning today are doing it in this manner. Okay, again, this is important, guys, and we should know about it. And I'll repeat that again. Practically in 2025, LoRa and QLoRa, they've reached to the stage where now we can use it in a very good production level scenario. And where what we do with the help of these specific strategies is, instead of retraining the entire billion parameter model, multi-billion parameter model, you train a small adapter layer, which is from the perspective of fine tuning. And you just train millions of parameters, which is like a very small cost, and you get the same domain specialization. One thing which is worth knowing, guys, there is a particular thing which is called as, it's a open source library, and you guys should look at it. RAG, and Atoli, ATOU, and I'll share the link. Ragatoli, that's the name. The way they have given is RAG in capital and Atoli in like small letters. Ragatoli is an open source library that recently made Colbert style retrieval accessible without custom code. Again, this is very, very, very powerful. So you understand what is a BERT models? These are like good models with named entity recognition, where you have BioBERT, other BERT models which are out there. So BERT models are like, these are completely based out transformers. So you can now bring research grade retrieval into a fine-tuned pipeline with very few lines of Python code. And that is taken care via this open source library called as Ragatoli. So you guys should look into it. It integrates with LangChain and LlamaIndex. And this is something which is very, very, very powerful. So if something is like, that's why it's very latest, because we all know LangChain, LlamaIndex, they're like now is something which are like a lot of multi-agent framework are built with even LangGraph. So at least we should know about it, and you guys should research. Again, the link will be shared with you guys. Now, I'm going to jump towards the word which I've used, which is called as LlamaIndex. Okay. And again, if you're building a RAG system, this will come up on a very regular basis. It's a powerful library for building scalable RAG systems. When you are building scalable RAG, most important thing is the way you are trying to query, which is like query at multiple people trying to get information from multiple different directions. So if you look at the code also, there are 4 lines. Import simple directory reader, then you have service context, then you have vector store index. Let's say that you have legal documents from, let's say, a data folder which you are trying to retrieve. You create the service context, build vector store index, you create a query engine, and you have a working RAG system. Very small system. Okay. Now, the honest framework picture for 2026, because the time is evolving, and we need to know when we are discussing advanced RAG, it has to be in the context of what's happening in March, February, January 2026, because it has shifted a little bit. If you look at enterprise framework ranking from late 2025, LangGraph took the top spot for agentic RAG. Okay. So whenever we are talking about RAG, we get into agentic RAG, and with that, LangGraph is at the top, and we need to know why. In a very, very powerful headless scenario, it had a stateful system, multi-step workflows. And again, we need to understand, I'm talking about LangGraph, which is like a mechanism where you have states being maintained. And I'll do a differentiation between what's LangChain versus what's LangGraph, and maybe what's LangExtract. To just give you a one-liner difference, LangChain, when you talk about a linear pipeline, you think of LangChain. LangGraph is stateful, which has looping, indexing, then you have iterations, retries. So that means it's like a state managed system, and that's LangGraph. And it's a multi-step workflow with human in the loop controls, which is better than anything else right now. And it's important to understand. Haystack became the go-to for regulated industries. Its pipelines are transparent and auditable, which legal and healthcare enterprises specifically ask. LlamaIndex remains excellent for data ingestion and retrieval focused work. Again, the top 5 RAG frameworks at this point of time, if I talk about like, and if you want to use it for your own purposes, number 1, LangGraph. Number 2, Haystack. Then number 3, which is for a simple workflow based thing, LangChain. Number 4, LlamaIndex. And then Pathway. Pathway is like a more recent one, which is worth looking into. It's built specifically for streaming data integration. So if your RAG system need to ingest real-time data rather than static documents, Pathway is doing interesting things there. So what can be an example for it? Maybe this YouTube lecture need to have a real-time ingestion and question answers. Then you can use Pathway in that direction. So your framework choice should match your use case. Okay. So do not commit anything in the beginning. And I always say this thing, that first you define the problem statement, then you define the system component view, then you define the system context view. I put it on my X, LinkedIn, Instagram videos. So we should understand when we are solving a software problem statement, it's important to first break down the problem, build the system component view, system context view, and then what is the input, what is the expected output, and what are the constraints. Once you have these things there, then you basically start building. In this way, you you can choose whether I want to use Haystack, I want to use LlamaIndex, I want to use, let's say, the LangChain, LangGraph, or Pathway. That's how you choose it. Now, okay, we'll jump towards querying in LlamaIndex. Now, what is querying? Retriever classes fetch data from an index. Okay, you're basically fetching it from an indexing system. Index is nothing but like, you're like, in a very simple English language, you're indexing something. That's it. Okay, query engine processes queries and generate responses. The code shows this directly, where you can see you have create query engine, set the query string, call the query, and print the response. Very simple. Now, here's the thing which you need to think about before we go any further. In 2024 and early 2025, thousands of teams built exactly this. That they were doing exactly this thing, that you have a create a query engine, set the query string, call the query, print the response. Most of them are doing this. Okay. And then what you did, you just deployed it. And users were not able to use it as efficiently. Answers were very irrelevant. Like, what you had to do were, yeah, like even I did a lot of activities where I was involved in terms of checking how the answer is. Answers were not coming out accurately. They were not correct. A lot of times context was wrong. So, and then even like there were hallucinations coming here and there in that direction. So one simple answer for that, with everyone said, they said, let's blame large language model, because we know LLMs hallucinate. If our querying system is hallucinating and generator system of this entire thing is based out of a large language model, that means maybe this is the problem. So what they did, they swapped the base models to a more expensive one. They thought that, okay, in my RAG, currently I'm using, let's say, maybe GPT-3. I'll switch to GPT-4. I'll switch to GPT-5. So I'll use a more expensive model because I just quickly blame the large language model. But again, you'll see that the problem will not be solved with that just by changing the model. And again, I'll repeat this because this is a very practical thing which I have been facing, and I've seen people do a wrong activity to solve it. So it is like in 2024 and also in early 2025, one of the things which happened was when you were doing the basic activity of RAG, which you can also see from the code, what happens with that, you get wrong context a lot of times, you get hallucinations a lot of times, and the only thing which you can blame for is an LLM. Where exactly? Okay, first of all, just to be clear so that you guys understand, when I say LLM in a RAG, where exactly LLM is being used? When you are doing embedding generation. Why? Because you'll basically save the data in Pinecone or VectorDB. So what you do, you get the documents, you chunk them, and then you generate the embeddings. Okay. Number two, when you are asking a question and it's getting an answer, it uses a re-ranker. So ultimately, it's again using the same mechanism for doing it. So that's important to understand where exactly the two places, generative answers, and number one, where did we mention? It's the embedding generation there. But while it is being used only at these two places, you just start blaming an LLM that context is wrong, or let's say hallucinations are there. Maybe the problem is large language model. Maybe we have to use an expensive model, which is wrong. According to research from 2025, 80% of enterprise RAG projects never make it past proof of concept. Reason being, the consistently, like, think about it, what's happening. If let's say your RAG system traced back to very small basic concept, you'll be shocked to understand chunking. And this is something which you guys should understand. 80% of the RAG projects are not able to make it to the production environment, and that is the research 2025. And the technical reasons can be very, very different. But one observation which was consistent, and it is across the entire life cycle, is poor chunking, poor query processing, and no re-ranking. Okay, we understand chunking. You have to chunk the document. The query processing mechanism is not accurate, and also the re-ranking is either not exactly how it should be or it was not present. So next slides are gonna explain that if you literally want to use it in the right direction, how can you make sure that from that 80% not practical POC, you can reach to the top 20% which are actually shipped and are being used. And that basically brings us to an important concept, which is query construction. Again, the three important reasons which I have given to everyone, which you guys should know and understand about, are poor chunking, then you have the re-ranking, and then you have query processing. So I'm going to jump towards a concept of query construction, converting natural language queries into structured forms. The slide shows why this matters. It ensures retrieved data matches the context of the query. Let's take the code. A function that replaces AI with artificial intelligence before the query goes to retrieval. Simple illustration of real principle. In production, this gets much more sophisticated. There's a technique that got widely adopted in 2025 called HYDE. Y small, hide. Hypothetical document embeddings. So instead of embedding the user's raw question and searching with it, you ask the large language model to generate a hypothetical answer first. Then you embed that hypothetical answer and search with it. Think about it. You must have never, like, you would have been directly putting your query inside the RAG system and thinking that, okay, fine, I may get an answer. And I'm basically giving you an idea, and you guys should look into HYDE. Hypothetical document embeddings. So instead of embedding the user's raw question question and searching with it. You ask the large language model to generate a hypothetical answer first, then you embed that hypothetical answer and search with it. Why does this work? Think about it. A hypothetical answer structurally looks much more like the documents in your index that a short question does. Okay, your short question is very different as compared to an LLM gives you a hypothetical answer. The embedding similarity improves significantly after that. For vague or sparse queries specifically, because users, you can't control what they ask you or your query engine. They can do anything. They can ask anything. Height consistently beats direct query embedding in retrieval accuracy. Important, HYDE. LlamaIndex and LangChain both have this now in a very built-in fashion. So again, what happened after that? Like there were new algorithms which came out, new mechanisms which came out. So now LlamaIndex has this built-in its system. This is the kind of improvement that takes you from that 80% to the 20% scenario moving forward. And again, I'll basically quickly be here in terms of querying. And so far I've talked about query construction. Now let's get into a little bit of expansion direction. Adding synonyms and related terms to broaden the search scope is important. The slide gives you an example: climate change expanding to global warming and environmental impact, and domain specific expansions like blockchain to disrupted ledger. The code shows a synonym dictionary looping through query terms and replacing them, and it's very straightforward. The downside is very obvious, and too many terms and you pull in irrelevant documents, noise is gonna go up, precision is gonna drop, and it's important that we balance some kind of retrieval scenario in this. So what evolved from this in 2025 was a concept which is called as multi-query retrieval. So instead of a static dictionary, you ask the large language model to generate 3 or 4 completely different phrasing of the same question. Run all of them, merge results, deduplicate them. Important. You run all of them. Again, I'll try to explain. So the concept is multi-query retrieval. So like what we just discussed, it basically goes and asks a question. So instead of just one static dictionary where you have the question, you ask the large language model to generate 3 or more complex different phrasing of the same question. And then you run all of them. And then what you do, you merge the results of whatever has come out. And then you also deduplicate them because maybe 2 of them have got the same result. So you deduplicate and covers a lot more semantic space which you could have skipped with one single query. LangChain ships this again by default built-in native manner. That means LangChain has multi-query retrieval present in it. Okay, now enterprises using customer support RAG system report that users describe the same issue in completely different ways multiple times. So one person says my payment failed, another may say transaction didn't go through, another says checkout is broken. Multiple query retrieval handles all 3 phrasings pointing at the same underlying knowledge, and that's why instead of, let's say, just having a single query, have a better query expansion mechanism to expand your query in that direction. And it's important to understand this. Now we'll quickly jump towards a concept of query transformation. Now what is query transformation? Altering the actual structure of the query for better retrieval. Important to understand. The example of this slide is very apt. What is the capital of France? Because Paris capital France for vector search keyword will have a dense keyword scenario. There'll be no conversational filter applied to it, and the code, the way if you look at it, will replace what is with find in that direction. So the slide also mentions optimization for SQL and graph databases, and this is a big deal right now. Text to SQL inside RAG pipelines went from search, like a very basic research scenario where they're trying to do it, to a lot of production level scenarios in 2025, and even I've used it. And the infrastructure news that makes it more significant, which is like multiple companies using it, and one example is Snowflake announcing agentic document analytics that lets you run RAG style queries across thousands of data sources, including structured databases, without pre-structuring everything. They pay $250 million for crunchy data to make PostgreSQL a first-class part of the stack, which we just discussed, and the wall between unstructured document and retrieval and structured database querying is getting as low as possible, and it's just collapsing. So if your data lives in a mix of documents and databases, which almost all the enterprises you see they have, your query transformation layer is needed to handle this scenario. So again, from an enterprise perspective, from a company perspective, the agentic RAG system, the advanced RAG system need to have a layer of query transformation. And again, we'll jump towards the concept of query engine, which is like a central orchestrator, the retriever, the transformer, the generator. The code shows the full LlamaIndex setup: load documents, create service context, okay, build indexing, create a query engine. And for scaling, batch processing and caching. If the query comes in repeatability, cache cache the results, latency drops, cost drops, infrastructure load drops. So again, it's important to understand, in order to scale, we have batch processing and caching. If the same query comes in repeatedly for people, okay, and this happens a lot at scale, you do just one thing: you cache the results. If you cache the results, the latency will drop, the cost will drop, and the infrastructure load will also drop. Now, the bigger picture on where query engines are heading, it's important to get an idea about that, because it changes how you think about everything around the same concept of a query engine. Right now, the query engine follows a fixed linear path where you query in, you retrieve, you generate, you get an answer. But in 2026, this linear pipeline is becoming a reasoning loop. The system decides whether to retrieve at all or not, evaluates if the retrieved content is good enough or not, and it loops back if it is not, which was something which gives a much more powerful production ready power to the system. And that is what we call as an agentic RAG system. Somebody is raising hand, I'm not sure, but we'll basically get it involved. Guys, raise hands if you have, let's say, anything there and you're able to understand things. I'm going to take a quick pause right now. If I see everything is able to understand, everyone is able to understand. So I'm going to quickly jump towards a much more powerful thing, which is like the bigger picture on where query engines are heading towards, because it changes how you think about everything around it. So what I was saying is, query engine follows a fixed linear path. You do a query, you retrieve, you generate answers. But in 2026, this linear pipeline is becoming a reasoning loop. And whenever I say reasoning loop, always get into the agentic mode, because I'm talking about agentic RAG. And the industry investment behind it is like just staggering. Like Meta put in $14.3 billion into Scale AI for data labeling. IBM is acquiring Confluent for $11 billion for data streaming. These are not small bets which people are putting on agentic RAG systems. So again, the very first thing, RAG is it? No, it's evolving at a very fast pace. The basic one is no longer something which one need to use. They should basically get into what's happening in February 2026. The company spending this kind of money are building the infrastructure layer that agentic RAG needs to operate at scale. And we'll basically get into a little bit more detailed scenario, but I'm going to quickly jump towards a concept which is called as sub-question, query engine, and how this should be used. Again, so what's happening? You break the complex query into manageable sub-questions, combine the answers with those sub-questions which are coming out. This slide is give you a very interesting use case around it. What's the impact of AI in healthcare and education? One question, but there are two relevant contexts to it. The code, it creates the sub-question engine, okay, and then it get the sub-queries, synthesize the answers, and each piece answered against the right data is combined into one single response. So the pattern from the slide is this early version, which basically was like, if you would have heard about in the very beginning when the multi-agent RAG in 2025 came out. So instead of one engine breaking things into sub-queries, you have multiple specialized agents running in parallel with an aggregator synthesizing the end result. Like one thing which came out was Microsoft AutoGen and LangGraph both supported this natively. And this is important to understand. And for example, I've used AutoGen, but I'm a big fan of LangGraph, and that's what I use almost regular basis on a lot of products and projects. Now, what's worth noting? This is the architecture behind tools like Perplexity's deep research. Take any example, big example. ChatGPT, it's deep research mode. Your large language model, you must have an option of deep research mode if you get into a paid manner, a paid account. All these products are using this by default inside the system. So when you use one of these tools, and when it says that I've searched 15 sources, that's a multi-agentic retrieval architecture doing exactly what we are describing right now. The pattern here is the foundation of these products, and the evolution is also happening in that direction. And again, now we'll quickly jump towards a concept which is called as custom retriever engine. It creates a retrieval engine to fetch data tailored to this query, domain specific indices for very precise answers. So let's say you have the code where you have create custom retriever from your index, set query retriever, clean interface, your own logic is built underneath it. Now, default retrievers don't understand how domain specific vocabulary works. A generic retriever built for general web text will miss nuances that matter enormously in, let's say, legal contract, medical literature, defense intelligence, everywhere. Okay, so here again, you remember I talked about a tool which is called as Ragatily, which was open source. You basically can use that in terms of an improved system. It's free, it's open source, you do not have any paid tier or anything like that, and it wraps itself around Colbert V2, which keeps token level embedding for fine-grained matching rather than one vector per chunk. Okay, in the old RAG system, you had one chunk, one vector. It doesn't do it. It basically does it in a different manner, and it makes it accessible without any custom code written on top of it. So again, regularly something to explore in terms of the custom retrieval engine. It works with, like, you must have heard about FAISS embedding. The Milvus you must not have heard about, but there are a lot of embedding mechanisms which you can use for any base retrieval mechanism. Okay, now there's a benchmark which is called as BEIR benchmark, which basically gave a very powerful outcome, and which I've talked about, the Colbert V2, and it came out in February, consistently outperforming standard by encoder retrieval for domain heavy context. Again, we'll share the link. So by default, you don't need to go and write some custom code, just use these open source libraries to do it. Now, one of the most important thing, again, if you remember, and I'll basically quickly jump towards it. If you remember one thing, we discussed an important segment here, which was 80% of the things do not go to prod when you're building RAG, and only 20% of them. And one of the things which I talked about out of the three was re-rank, because a lot of people either are not doing it or are doing it in a very incorrect manner. What is re-ranking? It reorders retrieve documents to improve the quality, meaning it gets the document and tries to figure out which one should I show first to the user, the second, third, fourth, fifth. So relevance scores determine which documents actually go to the large language model. So the code shows, from the code, if you look at it, what it is doing, it give it a query, you get the documents, you have the top end, you get back the results sorted by true contextual relevance and not just vector similarity. Important to understand. The first retrieval pass uses embedding similarity, which is good but can be imperfect. The first result is not always the most relevant one. Re-ranking runs a smarter second pass, and I'll tell you this thing, it's like a default for you for any production pipeline which you're building, which is, let's say, retrieving more than 5 documents, you have a second pass. So in 2025, there are multiple things which came out around this. One of them is cross encoder re-ranking, where query and documents are processed together in one model pass, both query and document, significantly outperforming the by encoder retrieval. Okay, so we need to know that these things have come up and we shouldn't be using the default mechanism which we used to. Haystack made this as the first class feature present by default. Remember I told you about different RAG which are quite popular, which are being used. One of them was Haystack. Anthropic published this contextual retrieval before, let's say, indexing itself. So we need to also look at this, and I'll share the link of this too, where they published the contextual retrieval, in which we prepared a brief context summary to each chunk, explaining where it sits in the larger document. So what you are doing, you are basically also adding a small bit of summary for each chunk, explaining the metadata of it, where it is sitting in the larger document. That context travels with the chunk forever. Their benchmark showed that this reduced retrieval failures up to 49%, which is a big number. Okay, again, I'll explain. So what you do before you get into the indexing and you index the chunk, a brief context summary to each chunk is basically created, explaining where it sits in the larger document. That context travels with the chunk all the time whenever we are trying to extract this. And the benchmark has shown that this has reduced the retrieval by 49%, almost nearly half. For a pre-processing step, that's relatively simple to implement, but it gives you one of the best accuracies which are available right now. So again, it's important that these things are critical, which can significantly improve your RAG to a very large extent. And I'll quickly jump towards the advanced retrieval concepts. And there are 3 modes. One is the semantic search using vector embeddings, which retrieves based on meaning. The keyword matching, which find the exact terms when you try to search something, it's a keyword. And then you have the third mode, which is the hybrid search, which mixes both of them together. The code hybrid underscore search, if you look at on AI healthcare, one call, but you have both the approaches together. Now, it's important to understand a concept which is called as recursive retrieval, which we'll basically cover later on, but a major infrastructure shift from 2025 that changes the entire dynamics of it. Traditional databases added native vector support to them. Very important, guys. Like, we are using databases for a while now. They've started adding native vector support, which is a big thing. PostgreSQL with PG vector, you have Oracle, MySQL variants of the same present, and the investment behind PostgreSQL specifically is humongous, is remarkable. Snowflake paid, again, you remember, it paid $250 million for crunchy data. Again, doing the same activity. Database spending billions on Neon. Superbase raised $100 million at a $5 billion valuation. PostgreSQL is turning 40 years old in 2026. And with this PG vector and all, which has come out, it's it's much more relevant now. But still, we are not exactly using it in that way. We can actually transform our existing infrastructure based out of these SQL databases, adding a vector layer to it, and it can basically do marbles for us and can even be faster. So we need to know how and what need to be done with that. You don't always need a dedicated vector database layer. It's important that when I'm saying this, you understand that it's not always needed. But for many production workloads, like you need to think about what's the use case where, let's say, you are handling millions and millions of data at scale. Your performance completely changes if you have that, especially with, let's say, data extraction scenarios. Maybe you have put some logs here and there. You need to check whether your existing database is having a support to it, whether your use case is defining it, and then maybe you can quickly jump towards using it. And now I'll jump towards a very common word, recursive retrieval. What you're doing, you are iterating and fetching related data over multiple layers, and that is why it is called as recursive retrieval. What do, you query in, your documents are out, those documents reference the other relevant documents which are then fetched from there. So you have created a layered the way it is being saved. So first you query the first layer, then that layer referred to the other layer, and then you retrieve from there. That is recursive retrieval. Okay, where let's say you have related medical papers, legal clauses, medical research. A paper cites 5 others. The way you have research papers and there's a citation, not basically they have a direct relevance. So then you jump towards those citations and move from there to there. In similar scenario, you have legal documents which can refer to other clauses. There can be citations from other judgments, and you need the chain. So the code is very simple. The recursive retrieval, let's say in AI and healthcare, you do a simple call, do a smart iterative logic underneath, and start doing the retrieval, which is recursive retrieval. Now, the concept is the foundation of Graph RAG. And again, guys, I've been using it and it's humongously powerful. And Microsoft is also, like, if you just look at the news, Graph RAG got open source 2025 even by Microsoft with some of its own variants. It was significant. Recursive retrieval is like linear, follow reference A to B to C. But with Graph RAG, it builds a full knowledge graph. So entities become nodes, relations become edges. Okay, it's important to understand what a Graph RAG is and how it is very powerful. So now the question will be like, what are entities? What are relations? So for example, let's take a sentence. Aditya has a MacBook laptop. Okay, or Aditya runs 5 miles a day, or let's say Aditya does XYZ. Okay, now we need to know that there are 3 things which comes in. You have entities, which are Aditya is an entity, XYZ can be an entity, and then the relation joining the 2 entities is the relation. So that's how you build a knowledge graph. So wherever you will see Aditya as a term, it will index it and make sure that Aditya node wherever. So you create a 3-dimensional picture of a knowledge graph. Okay, in a graph RAG. So if you ask a graph RAG, how did this founding team's background influence the current product architecture? Standard vector search finds documents about the team and documents about the architecture separately. It cannot connect the influential relationship between both of them together. But if you use graph RAG traversal, the graph and the surfaces that connect them explicitly, the results are significantly different. And that's why graph RAG is at the top of the game in this whole thing. So in early 2026 benchmarks, we can see clearly that graph RAG is achieving search precision up to 99% on complex multi-layer enterprise queries. Very important to understand. What's the trade-off? It is 3 to 5 times more, let's say, LLM dependent in terms of doing LLM calls to build and maintain on a very regular basis. So it's like you have a little bit of higher cost deficit with respect to LLM, but graph RAG's accuracy fetching scenario is much more better. And I've been using it, so I know how powerful it is. So for domains where accuracy is non-negotiable, let's say defense, legal, medical, cost is completely justified. So any kind of RAG you build, you should make sure that like use open source graph RAG systems for doing it. Now, small to big retrievals, if we look at it, we start with a narrow query, expand for context, small chunk for precise matching, larger surrounding chunk for context. This slide is going to help you get to the frame in that direction where relevant chunks are retrieved without overloading the model. Let's say legal contracts are being fetched. The small chunk finds the specific laws. The bigger chunk gives you the surrounding context the LLM need to interpret it properly. So the code is small to big retrieve with the query. So you are basically having a version like small to big retrieval version, and very small concept, but it basically helps you increase the precision of your RAG to a very large extent. So what do? You go towards the precision first in a context second scenario. So now chunking strategy become a serious research because you have seen, and I've told it before, most of the 80% RAG systems, they are not able to go to prod with their lower precisions, even with better large large language models because they either had a problem with chunking strategy, they had a problem with re-ranking and the things which I mentioned earlier. So it's important that we give a little bit of, let's say, pace to improve this, and that was happening in 2025. And I'll give you a couple of examples. There's a company, Flowtorch. So Flowtorch February 2026 benchmark, they actually give you 7 chunking strategies across different papers. So what they did, they tried to produce different strategies and see which one is giving me better benchmark score. The winner wasn't always the most sophisticated approach for chunking. What the study confirmed is that no single strategy wins universally. The write-up depends on your data structure and your query type. Important to understand. So you can have, let's say, big and small query chunking. You can have chunk plus metadata related information with chunk. Different chunking strategies can be used for different types of data. Mayo Clinic published a clinical AI paper in November 2025 evaluating 4 specific strategies. And again, semantic and adaptive chunking significantly outperformed fixed size chunking for clinical accuracy. Again, as I mentioned, domain specific, niche specific, data type specific. One of the observation was you have semantic and adaptive. What is an adaptive chunking? It's like you're trying to adapt on the basis of the data you have, the size of the chunk which is used. So you basically get the context. Semantic is like embedding generation, but on top of it, the size can be adaptive, changed depending upon what you want to put it in your single embedding. So there is another one which is called as proposition based chunking, where each chunk is a single atomic fact which showed highest precision for very specific kind of data, which is like a fact retrieval. If you have facts which are like plain single fact, simple facts, then for that the idea was to use proposition based chunking, where each chunk is a single atomic fact. And for tables, let's say you have a lot of tables, never split rows across chunks. Guys, important to understand, a lot of times when you're trying to do table based chunking, where you have a lot of tables and you want in a document or any place and you want to chunk it, never split rows across chunking. A row without its header row is completely meaningless. So let's say you have a big table of 1,000 rows, you ensure this, the table needs special parsing before they go anywhere near your index. Guys, this I'm not sure how many people are gonna get into. They would have explained maybe in your companies if this thing is being discussed, but you would have seen most of your documents have tables. One thing which happens in the tables, we just use the normal method to just, but we should always ensure a couple of things. Parse the entire row, and the row without its header row is completely meaningless. Important to understand, and then accordingly do the row based chunking or the table based chunking. Now, let's jump towards production ready RAG solutions. Okay, scalability, reliability, latency management, continuous monitoring. It's important we basically have these things in our when we talk about production ready RAG system. And you can see from the code, like the Elasticsearch setup, create connection, create the index, your production retrieval foundation. So 71% of organizations using generative AI, and only, let's say, out of those 17 getting real business value. One of the things which I explained about it from McKinsey, which happened in 2025, the organization closing that gap are not the ones with the best models. Guys, we need to understand, it's not the model where you use, let's say, Anthropic or let's say ChatGPT, or you're using the best of the best version. They are the ones which have the right system design. They are the ones which have the right infrastructure setup. And again, there are a lot of acquisition news which we discussed, where Zendesk acquired this Unleash in December 2025 to bring enterprise RAG into the support platform. Why? Because they know that this basically changes the game for them in a very scalable direction. Workday embedded RAG for their human resource policies, Q&A. ServiceNow built it into their IT workflow platform. And these are not experiments. These are literal production level things which they're doing in 2026. And we are talking about thousands and millions of employees using daily for running RAG infrastructure that need to be scalable, reliable, low latency, and being monitored on a regular basis. One requirement that emerged strongly in 2025 was answer attribution in production RAGs. Not just is this accurate, but which sentence from which document support each specific claim. Legal firms and financial institutions require this for any RAG deployment, and we need to understand this. So it's not just about whether we have extracted the right answer, but what is the source of it. So we have to build attribution logging into our architecture from very beginning, and it is something which you cannot skip whenever you're thinking about building these RAG systems for production ready environments. And now I'll quickly jump towards document updates and stored vectors and the way the actual operations happen around it. Okay, so your index, let's say you have 10,000 documents and you have indexed them. 3 months later, 500 documents have changed. Now you don't rebuild the entire index, guys. Okay, this is important to understand. Don't rebuild the entire index. This slide specifically shows the solution around how you should be doing it. And let's say you have deep lake vector store. You call the update with new documents and just update what has changed. That is it. Okay, in the code. So let's take an example of Workday, or let's say one of these companies. That's how they're doing updates on stored vectors. The audit trail requirement is showing up almost everywhere, where you have to ensure that what has been done is updated and changed. That trail is maintained when you're doing it. So you need to maintain some kind of audit concept in the system when you're doing these kind of activities. I'll basically quickly jump towards the next slide, which is chunking and data distribution. Again, very critical, very important. I've seen systems fail because, like, most of the time, like, and this is something which, let's say, as an engineer, when I'm working, I just know the fact that it has to chunk. But there are a lot of chunking algorithms, chunking strategies. But again, most of the time, because we do not first understand the kind of data we have, and on the basis of we should decide the right chunking strategy, we just ignore it. So from the code, let's say you have chunk size 512, you have chunk overlap of 64. Again, important concept, guys. This is something which is an old concept. You have an overlapping chunk so that you can ensure that when you have the next chunk, the previous context is maintained a little bit before it moves to the next one. So you always have some kind of overlapping chunk. Reasonable starting point from where you can start thinking about building a much more bigger scenario. Now, without overlapping, a sentence spanning two chunks gets split and both halves become harder to retrieve accurately, guys. So it's important that whatever you're doing, always ensure that you save some particular bits for overlapping. Now, Flowtorch's February 2026 benchmark, which we discussed for a lot of other purposes in a previous slide, they had some interesting findings. And as I mentioned to you, the winner for figuring out the chunking is, it is like which data type and which query type the people often use. And again, you remember I talked about the semantic chunking scenarios, splitting on meaningful boundaries, and rather than just thinking about, okay, token num counts. So which is adaptive chunking. So for example, let's say I say I have 512. I shouldn't be just specifically saying 512. It need to be adaptive. It need to be semantically controlled. And if you do these activities, you will outperform the fixed scenarios, the fixed chunking scenarios. And again, this also brings up the part of table, that the way you should be doing chunking for tables. And now I'll quickly jump towards an important thing, which is compliance. This particular code which you see here, it shows a pernet encryption. You generate the key, create a cipher, encrypt the sensitive data before it goes into the index. And it is important. It is very basic, but most of the time it is skipped. We are not even caring about it. We think about building production RAG systems, but we skip some of the things which may be needed in very critical scenarios. And in 2025, guys, and this is an enforceable law and not a guideline, European Union AI Act enforce with obligations running through 2026 and 2027. India's Digital Personal Data Protection Act now is active, and there are GDPR and HIPAA compliance, and these are all global baselines. And that is why you cannot skip this important activity. If you are retrieving personal data, you need a legal basis. You need logs of what was retrieved for which query. You need the ability to delete a person's data from your vector store on the request. Selective deletion from a vector index is technically non-trivial, and most teams don't even think about it until their lawyer asks, or they're thinking that, okay, maybe we'll do it at some later stage. Okay, it's not technically like I'll just do it immediately and it can happen. Again, I'll explain this. I've talked about the EU AI Act. I've talked about India's Digital Personal Data Protection Act. There are GDPR, HIPAA compliance. Ability to delete a person's data from your vector store on request. It's a legal requirement. Okay, if you're basically doing anything on RAG with personal data. So the security angle gets serious attention, and it was quite, let's say, something which was talked about a lot in 2025. So there is this convention, like you must have heard about OWASP, LLM. Top 10 now includes RAG specific attack vectors, bad RAG and Trojan RAG. Okay, there are malicious documents which are injected into your vector index to trigger specific model behavior when certain queries come in. And these things are pretty common and you must know about it. You should be aware about it that these things can happen, which we call as poisoned retrieval. Term it and then you guys can search about it. Bad RAG, Trojan RAG, where malicious documents are injected into your vector index to trigger specific model behavior when certain queries are extracted or used. And this is poisoned retrieval. These are documented real attack patterns that appeared in security research last year. Building a RAG system for an enterprise client without a security review of the retrieval layer is going to become a huge liability, guys. So you should at least be aware about these, okay, of how it is happening. And with this, I'm quickly going to jump towards optimization, like indexing strategies, query caching, parallel processing, top K tuning, these concepts. Okay, if you look at the code, you'll see thread pool executor with 4 workers, queries processed in parallel batches instead of sequentially. That's the parallel processing point from the slide, which is important to understand. One technique from 2025 that isn't on the slide but gives you a very important and a direction to look at is called as Matryoshka embedding. And again, I may not be pronouncing it accurately, but definitely I'm going to share it because I have used it, guys. So traditional embeddings have a fixed dimension, say 1536 for OpenAI's models. Matryoshka embeddings are trained so that the first 64 dimensions already capture the most important semantic information. You use small dimensions for fast initial retrieval, full dimension only for final re-ranking. Wow, think about the optimization which it did. It just basically made it very fast. So storage cost gets down to a very large extent, latency becomes very less, and final answer quality is maintained. And again, I'll share the term, but it's called as Matryoshka, Matryoshka embeddings. So you guys should look into it. OpenAI Cohere and the top open source embedding models on the MTEB leaderboard, and I think it should be on Hugging Face too, which you should look at. All this training approach which is being used is designed in terms of figuring out these kind of techniques. Okay, so if you're choosing an embedding model for a new product, check whether it supports Matryoshka before committing to that embedding model. Okay, guys, so important to know about. I'm sure maybe not a lot of you have heard about it, but you guys should look into it because that's what you should be using in terms of the retrieval. The performance and cost benefits in the production are humongous, and that's what we look for as a ROI when we are trying to use AI for organizations. Okay, now I'll jump towards the model selection and the hybrid retrieval concept. So open source versus commercial, keyword plus embedding retrieval combined, how and what need to be done here. So if you look at the code, there's this hybrid retriever combining the embedding model and the keyword model. And this is something which I also use. So retrieve on a query, one retriever, and you use both the approaches. If you look at the model landscape, it has just changed significantly. Open source genuinely is basically at the top of the game. You had Llama 3, you had Mistral, you have Quinn. For many RAG use cases, these are competitive with commercial APIs of OpenAI and all. Okay, the MTEB leaderboard in early 2026, I'm talking about Jan, February. The standard benchmark for embedding models has open source models from BGE, Nomic, and the E5 family within striking distance of OpenAI and Cohere on most retrieval tasks, guys, which is a huge jump. That means for a lot of sensitive data, we don't need to depend on the models which are basically already commercialized. So it's important to know about it. And again, as I mentioned before, it's not the model, it's the architecture and the design of your RAG system which gives you a better result. Okay, so we need to know about it and ensure that while definitely if you use a 200 million parameter model versus a trillion one, definitely a trillion will give you a better result. I'm talking about comparable models. If they're very comparable, just have a better architecture, it should be fine for you. So you need to know this. And for the generation slide, Claude models specifically have shown consistently strong faithfulness to retrieve context in production RAG evaluation. So when you feed Claude retrieve documents, it tends to stay grounded rather than wandering into hallucinations. For use cases where faithfulness is critical, that matters more than raw benchmark scores, it's important that that we know about and we understand. For retrieval specifically, the top 5 RAG evaluation platforms at this point of time, guys: Maxim AI, LangSmith. Okay, guys, you should know about LangSmith because something which a lot of times is referred. So just search about it. There is LangExtract, LangChain, LangGraph, all these others. Then one of the good benchmarking basically which comes in is DeepEval. So we guys, whenever we are doing these RAG systems, we basically always ensure that we have been doing the benchmarking and evaluation. Now I'll quickly jump towards very important thing, which is CPU based inference. Term is good enough. Like ROI of the company can be quite good if you are able to do that. So it is important to understand that inference is expensive, especially the GPU inference is very expensive. CPU reduces the cost significantly. Model optimization makes CPU viable. Device map can be auto in the code where your library can pick up the best available device automatically. So when you're building the RAG system, you should always have a CPU inference scenario, and you should basically say that, okay, auto pick whatever is available. So GGUF format and llama.cpp matured significantly in 2025. Okay, and I explain why I'm talking about these two things. You guys can later on look at the slide too. So running quantized models on CPU efficiently is now completely practical. Sentence transformers, the embedding models most RAG system use, can run on quantized CPU and handle thousands of queries per day without any GPU needed. The quality drop from INT8 quantization is minimal for most relevant tasks which we perform on a regular basis. And this is coming from a practical user who has been using it. I've been doing it a lot. I've been using it in a lot of different directions, and literally you can run it with quantized models without having a significant drop on your CPUs. Now, this matters specifically for builders, let's say engineers who are doing it at a lower level, plus for organizations who want to ensure that they have very, very good ROI. So if you want to build a ROI, you need to ensure that your expense is less. At the same time, you're able to have a better margin. And if you want to do that, make sure that you have CPU based inferences. At least do some optimization to do that, and maybe have some kind of auto method in that direction. Now, I'll talk about retrieval performance. If you look at the code, you have create node network from documents, query against the network, and then you retrieve. So when one document is retrieved, related documents are automatically considered through the network structure. Okay, so it's important to understand that part, that the related documents are automatically considered through the network structure which is present there from the code, if you look at how it's happening. Now, the node network concept connects to a concept of self-RAG, which got significant attention in 2025. So in a standard pipeline, you always retrieve and query comes in. Retrieval happens regardless of whether it's needed or not. Self-RAG is different. The model first decides whether this query needs retrieval at all. If yes, it retrieves, but then evaluates whether what it got back is actually relevant before using it. If not relevant enough, retrieves again with a, let's say, some kind of reformulated query. And after generating, it critiques its own output for faithfulness before returning. And that's what self-RAG is about, and that's what we should be using on a regular basis. So this element, like if you look at it at a very high level, you're eliminating two real failure modes. One, retrieving when you don't need to, and accepting bad retrieval without questioning it. Okay, self-RAG showed measurable hallucination reduction in the 2025 benchmarks. It requires a deliberate loop in your architecture, not a single function call. But for high stakes systems where a wrong answer has real consequence, it is worth the complexity with which it comes in. Again, guys, important to consider, important to know about. These are basically the systems which one should be using. So like at the time of retrieval, you're trying to improve the performance in two directions. Number one, you're not accepting the results where there is a bad retrieval and you're questioning it. And number two, you don't even start the retrieval when you don't want to or you don't need to. So that's basically what the retrieval performance is about. Now, it's important to understand the depth of this retrieval role. Okay, if you look at the code, you have Elasticsearch searching the documents index for quantum computing. That one query determines what the large language model sees, what the LLM determines, and when it says. Get that wrong and nothing downstream can fix it because you have just extracted it. So my practical approach on every project which I'm working on is test retrieval completely independently before connecting it to the large language model. Okay, that's what I've been doing. I've been doing this activity in all the different organizations. Okay, so I test the retrieval completely independently before I connect it to large language model. I write 20 to 30 queries, look at what exactly comes back, read those documents. Are they actually relevant? If not, I first fix the retrieval. Do not just jump towards LLM and try to think that I want to solve the upstream problem that LLM is an issue. Now, RAG is a context engine, not a retrieval pipeline. You need to come out of the mindset of what used to happen with RAG versus what now RAG is. Okay. It manages what reality the LLM operates in, which facts it knows, how currently they are functioning, how recent they are, what kind of recent data they have, how verified they are. The retrieval step isn't a search bar. It's the intelligence layer that determines what the large language model believes to be true when it generates an answer. 85% of the enterprise AI applications are going to be using RAG in the next 4 to 5 years as their foundational architecture, guys. 85%. And that's something which I'm telling you right now. Maybe we'll come back in future and see if that's true now. Okay, right now this number goes to about 30 to 40% at only at very high level scenario. If you look at the reality of almost every small company using it, it can even go below 10%. The teams who understand this deeply today, who can design, build, evaluate, and operate these systems properly, are positioned for much more larger impact in the industry. And again, this is the term which I call it, and you guys should know about it. I call it aware. So you had waterfall method of SDLC cycle, then you had agile. Now agile is something which I believe is not at all relevant. The thing which according to me is there is aware, agentic workflow for adaptive real-time evolution, guys. And this aware framework is something which basically is gonna evolve. And the people part of that aware framework are the people who can design, build, evaluate, and operate these systems. But the execution layer is taken care by our agentic platform. So you are basically thinking at the systems level. Very important to understand. Now, if you look at this code and some best practices, you have refine query first, retrieve with advanced query second, refine before you retrieve. That sequencing is important, and it basically gives you some level of idea about some practices which should be followed. Now, 60% of new RAG deployments at this point of time include systematic evaluation from very beginning. That's something which has evolved from, let's say, earlier it was around 30-25%, and now it is like around 60% and more. And these are all data which are present in corresponding statistic and news articles. The industry genuinely learned from the wave of failed deployments which happened for a long duration back in 2024. The teams that are succeeding are the ones who build evaluation from the very beginning. Always ensure that you have some kind of evaluation framework while you are building this, not as something which is like an afterthought or we'll do it later on just for the compliance purpose. So evaluation should be thought from the about and built from the very beginning. Like I'll tell you about the debugging framework for this, which I actually use. So wrong answer comes out. Okay, and this is something which you guys should think in your mind. Let's say you get a wrong answer. First question, was the right document even retrieved or not? Well, first thing. Number two, go look at raw retrieval results. So you look at the results, you see if that document is not. If no, if that document is not present, chunking or retrieval problem is present. That's how I try to debug. If yes, if the document is present, was it ranked highly enough or it was ranked lower? If it is not ranked high enough, that means there's a re-ranking problem. And if it was retrieved and ranked well, but the answer is treated wrong, now and only now, it is worth questioning that whether I'm using the right large language model or not. You got the idea? I'll explain again. That's how you can debug when you have an issue with a RAG. You get a wrong answer, you get involved, you think about whether I have retrieved the right document from where this wrong answer has come. You look at the documents. You check whether the documents which I've retrieved, does any of these contain that right document? If no, that means you have a chunking or retrieval problem. So you focus there. If yes, you have got that document, then you think about, was it ranked highly enough? Was it present at the top 5 or something? Or is it like way at the bottom? If it is not present in the top 3 or top 5, you have a re-ranking problem. And if it was retrieved and ranked and it was present in top 3, and even after that you got the wrong answer, now and only now it is worth questioning the large language model, guys. You understood? This is something which most of the people they skip thinking about, and they just directly blame the LLM for it. So I keep seeing the team skip straight to blaming these large language models, and almost always the problem is three steps earlier. And so ensure that follow the sequence when you're trying to debug a large language model. Now, again, we talked about the entire thing. There is one important concept which is basically embeddings. Okay, and this is quite important and we should be knowing about it. So fine tuning the embedding model is very interesting. Most of the time we are using some OpenAI key to generate embedding or sentence transformer, but there are a lot of times which can took you to a level where embedding model training in some way or the other. So there are BERT models, BERT tokenizer loaded from pre-trained BERT-based uncased fine-tuned on domain-specific data. Okay, so like there's a very clear example. Default embedding models are trained on general web data. For specialized domains, medical, legal, finance, defense, they miss the vocabulary nuances that matter for retrieval accuracy. The data requirement dropped significantly in 2025. Synthetic data generation using large language models made embedding fine-tuning accessible to teams without large annotation budgets. And I have been doing it for a while now. Important to understand. Generate synthetic question answer pairs from your own domain documents. Use those as your training signal, and it is even practical for very small teams. So that's how you should be able to generate the data and then basically do some validation on the generated data and start using it for fine tuning. If you're choosing a base model, the MTEB leaderboard is where you should look at. Okay, always ensure that you're having the Hugging Face access, leaderboard access. Look at the best open source models out there. On the basis of those open source models, check for the cost and then basically move towards the fine tuning part in terms of using it. Now, again, we talked about the embedding fine tuning. There are basically scenarios where you may need to involve, let's say, LLM fine tuning. So large amount of labeled data, significant computational power, all these are basically challenges which come with the LLM fine tuning. And the process is as simple as it can be from the perspective of theory. Complexity is there for a lot of other things. So data set preparation, training, and then you're doing the evaluation from that perspective. So if you look at the code, it shows Hugging Face trainer, training arguments with output, directory, and batch size. Trainer created the model and arguments like trainer.train, that's the skeleton. LoRa and QLoRa, we talked about it earlier, change the economics of doing this fine tuning drastically, guys. Okay, because like we understand these are big models and the cost is huge, but adapted layer basically is being used instead of the full model, and this is important for all of us to understand. So we can actually train the adapted layer, make it more domain specific. So again, whenever you're fine tuning, always just have an idea and understanding of LoRa and QLoRa. Millions of parameters can be used instead of fine tuning or training billions of them. So QLoRa add quantization during training, so you can fine tune on hardware that would have not been possible at all or would not have been an adequate way of doing it. So you can have lesser hardware, that means lesser cost, smaller time, by using LoRa and QLoRa for fine tuning. The decision sequence which I actually use, okay, and it is important to understand this decision sequence. You start with prompting. Let's say if your accuracy is insufficient, your accuracy which you're getting in terms of outcome is not very good, add a RAG in the system. If domain language understanding is specifically the barrier where your domain, the way outcome should come, let's say you're doing a legal judgment based, let's say litigation drafting scenario, any of these activities, medical, the domain language, clinical scenario, domain language different, then if the domain language understanding is specifically the barrier, add embedding fine tuning first. Okay, what we just discussed in the previous. So you do an embedding fine tuning. That's the cheapest and the fastest way to improve it. Only if you are done with all of that and you're still not hitting your target to do your, let's say, get the better result, then finally you jump towards LLM fine tuning. Most of the time, what we do is instead of, let's say, going through the embedding fine tuning step, we directly jump towards fine tuning the model, which is too early. So it feels like the most powerful thing to do and will give a result. But again, most expensive and slow to iterate on, to improve upon. So again, mechanism, the thought process. If accuracy is coming out in insufficiently, you've added the RAG. If your domain language understanding is specifically a barrier for you, add the embedding fine tuning first. Then you jump towards cheapest and fastest. Only if you're done with all of that and you're still not hitting your target, you basically jump towards the LLM fine tuning, guys. That's how you should be doing it. Now, it's important to understand in production what are the different standards to benchmark a RAG system. Okay, like if you look at the code shows correctness, relevance, faithfulness. These are the benchmarking parameters. So, how do you benchmark something? You take a gold standard data, gold data. There are some gold standard data already available out there. Then you use that gold standard data and you run your own RAG system and compare your answers. Now, again, if you're building a very domain specific scenario, there can be a high possibility that you have to generate your own manual human driven gold standard data, which is difficult to do it at scale. But usually, when you're building a generic RAG system, you have a lot of gold standard data already available, which you can use. And there are a lot of parameters, not one or two. Here in the code, you've seen correctness, relevance, faithfulness. The code shows the accuracy score against a ground truth. That gold standard, when I say, it's basically the ground truth data. In production at big standard, you have Ragas. Its purpose built for RAG evaluation, tracks all the different matrices properly. And there are other systems too, like LangSmith. Okay, LangSmith is something which you can use for a lot of other scenarios. There is basically Arise Phoenix for teams who need this as part of their continuous integration deployment pipeline, because ultimately, let's say you have updated something, you would want to see whether everything is good or not. You use deep eval, which uses PyTest style testing even for benchmarking, so you can catch any kind of quality decrement which has happened. It can be immediately caught at that CI/CD pipeline there before you deploy it for other team members to use it. The 5 evaluation and observability platform with which are something which you should be knowing about are Maxim AI. Okay, because now you're building RAG system. Let's basically look at the important evaluation, and again the term is important. I'm saying observability platforms, because ultimately these are like, there is a difference between writing a unit test case, integration test case, and doing benchmarking and evaluation around it. Okay, so Maxim AI for end-to-end lifecycle management, LangSmith for LangChain native debugging, Arise Phoenix for open source retrieval observability. When I'm saying it, don't need to think about writing it, because this will be shared, guys, with you. Okay, Ragas for the evaluation matrix framework, Deep Eval for production integration testing, guys. Okay, all these are relevant from the perspective of building a production ready RAG system. Now, faithfulness, and again, guys, it's important to understand some of these evaluation framework, because like, for example, if you've built something, how do you know something is correct or not? By just one query, two query, three? No, you need to run it with thousands of queries. That means you have to come up with an automation framework to evaluate your RAG outcome. And to do that, you need some ways to benchmark something. Okay, on the index of correctness, this one did this. On the index of faithfulness, this one did this. So faithfulness is the most RAG specific metric. Like from our current context, we'll jump into a lot of other parameters later on, but for the timing, just let's understand. If the model ignores what was retrieved and uses its own imagination, faithfulness fails. Understand this. If the model ignores what was retrieved at the time of running the query and getting an answer, and it just uses something on its own, the faithfulness just fails. So in RAG, that completely defects the purpose of retrieval for us. And that is why faithfulness, when you look at a RAG system and the benchmarking of RAG to select a good RAG, always check its faithfulness score. Answer attribution became a very hard requirement in regulated industries. We discussed about it, that you need to have which document it's supporting and not. And trace exactly which sentence from which document supports each specific claim. Okay, again, an important parameter to look into. So legal, financial, healthcare, they will not deploy RAG if you do not tell them that from where you have retrieved it. So again, if you look at the direction where it is going, evaluation and live systems are basically merging together, like having their own thing. Like you have things in CI/CD and then it goes to live. So continuous monitoring loops sampling the real queries, flagging quality, degradation automatically. Okay. So you need to basically get this idea that feeding signals back into retrieval and chunking improvements, checking the activities where you have a regular monitoring happening with, let's say, one by one different queries are being given. And then in a very real time environment, any kind of quality degradation which happens, it is being flagged. These are critical and important. Again, I'm talking about building and deploying RAG. So when you're building a RAG system, remember that your RAG system have a continuous monitoring loop on some queries running behind the scene on a regular basis. Okay, maybe at the time of CI/CD. And your RAG system has some kind of quality degradation flag that the continuous deployment quality degradation happened, it immediately flags it. Okay. And then like some signals being sent back into the retrieval for any kind of chunking improvement. And I'll tell you this thing, this 2026 year, you'll see a lot of research coming out in that direction. But with evaluation, guys, I think we are almost done with. And guys, you can basically just scan the QR code and like just follow the Insta. You'll be able to get into the different, I think, the Discord community, WhatsApp community, where I'll be sharing the presentation, the code base. There are a lot of open source code which is written and which you guys should basically get some awareness about. So again, like what we did today, what, like in industry, whenever somebody says to you, RAG is dead, show them this video. Or basically tell them that no, bro, it's not dead. There are so many things happening. You should know about it. And then you explain these concepts. Okay. So it's more about going much more bigger, wilder, better in that direction. Okay. So the numbers tell us a story very clearly. 40% of enterprise AI applications use RAG as foundational architecture today. Okay. Projections, basically, if you look at like what's happening and what I'm saying right now, is the number is going to touch 85% to 90%. And when I say 40% enterprise AI, I'm talking about only a specific niche layer. If I look at all the domains and everything, it's not even 10%. So the teams who understand this deeply right now, who can build and evaluate and operate these systems properly, are positioned way ahead in the market. And guys, when you are basically having conversations for your interviews, getting inside the AI, just have a very in-depth understanding. Almost every company need it. So this becomes like a basic check mark in your portfolio of having advanced RAG understanding and building advanced RAG. Okay. So like just like scan the code and keeping it for 30 more seconds so that you can follow on Insta, get an idea. There you'll get Discord community link. Most importantly, like there'll be workshops. Like I've talked about the OpenClaw workshop, the new things which have come out. And I'll also go through a concept of aware framework where I want you guys to understand that agentic coding is a must. So like you need to know how and what need to be done to automate the coding activity. And again, I do not need to explain why to basically follow and what to do here. I'll be doing a lot more different things. If you guys also have ideas, you guys can share like what I should be doing in my next videos, how I can be, let's say, maybe I'll give some more practical workshops. That's something which I'll be doing. But if you have topics, which topic should I cover? I would definitely want to know. Like maybe someone from the team will share a link where they can see the suggested topics, so I can choose those. But I'm going to be completing this large language model series, okay, which basically is very specific to understanding. And this is a very important pivot for all of us from the career perspective, that we go through the videos and understand it. Okay, so like another thing which I'll do is I'll share a form where, let's say, hands-on skills, some kind of mentorship if you need, some kind of consultation if you need. Like I'll basically share a Google form where someone from the team will connect to you for 10 minutes. Okay, maybe you can give an idea and they can like see if there can be some custom thing done in terms of your individual scenario and what can happen. Or maybe I'll cover a lot of topics together in an amalgamation form in the next time. So a couple of forms will be shared, guys. Be engaging. I think we can crack a lot of things in a very short span of time, and we can become one of the best AI engineers across the globe in that direction. But thanks a lot, guys, and it was fun having an interaction, and thank you very much.